Assalamu alaikum. Here we have a question on curvilinear motion, tangential and normal components of acceleration. We have here a roller coaster at point B, has speed is 25 meter per second, which is increasing at this rate, 3 meter per second square. Look at this is the tangential acceleration. Now the question says determine the magnitude of the acceleration at this instant, right? And what is the angle it makes with the x-axis. So first of all, let us start with the magnitude. The A as a magnitude simply is the square root of AT square plus AN square. Now AT is given, so we don't need to worry about that. AN, we can find it using this formula. AN simply is V square over rho, rho being the radius of curvature, right? Now let us, while we are explaining that, look at this. Since this curve is concaved to this side, now that is my, rho will be somewhere here. So this is the normal axis, and here this is the tangential axis. Okay, right. So the component of my acceleration would be somewhere here. I mean, this is the magnitude, right? So that is A, just A, and this is here just AN, and here this is AT. Okay, now since we have this roller coaster is just moving along a curve which is not constant, so we can find the rho here. We can find it using this relation. Rho simply is 1 plus 1 prime square, everything power 3 over 2 over y double prime absolute value. Right. Now y prime, if we take the derivative, would be 1 over 50 y, and x here, y double prime would be just 1 over 50. Now we can substitute these values here, right? And we'll find, I have found rho to be, so from here I found rho to be, yeah, before that, at which point you want to find rho, right? So what will you replace x here? Now since we are doing the calculations at point B, B is away from the x-axis 30 meter, so we'll replace x here by 30, right? In this expression, in the rho expression. Okay, so I did that. I found rho to be 79.30 to 4 significant figures meter. Okay, now I can find AN. So AN here simply would be 25 square over 79.30. Okay, so here I got the answer to be 7.881 meter per second square. And now we can find the magnitude of the acceleration just by using this. Okay, so now I got A to be 8.43 meter per second square. Okay, so that's my A. So now we are done with the first part, which is the magnitude of the acceleration. Now about the direction, let us establish here what should we, or what the question is asking for. The question is asking what is the magnitude, what is the direction of this, how much this magnitude of the acceleration is making with the x-axis, right? So here we need to be careful about what the question is asking for. To do that, let me draw the coordinate system we have. First of all, I have, that is my y-axis. Let me just make it a little bit better. This is the y-axis, and this is the x-axis, right? So y and x. And here, this is the normal axis, right? Which is toward the curvature, right? And here is my tangential axis. So this is the n, and this is the t, right? Let me just make this a little bit. Okay, right. So now what the question asks is that let me draw the magnitude of the acceleration, which was somewhere here, right? Now the question wants us to find this angle here, theta, right? Now I can simply find the whole angle here, which is just from here to there. Okay, let me call this, no, let me make it, let me say this. How can I find this angle? We call it phi, for example. Since I know AN, right, and AT, so both of them we know, we can simply say that tan phi, the whole angle here, would be simply AN over AT, right? Let me here just draw it quickly. So that is the A, right? And this is something like this, and this is here we have the T, AT, right? Let me make this a little bit more inclined. Okay, so this is the A, and here this is the AN. And we are looking for this angle now, for phi. So tan phi simply is AN over AT. And now if you replace that, 7.881 over 3, and we can find phi like that. So phi would be equal to, I did the calculations here, tan inverse 7.881 divided by 3, I got 69.16 degrees, right? So this is the angle phi. But the question in fact is asking for this small theta. How can we find that? Now we can find this by observing the following. Let me do this here. Let me extend this line a little bit like that. Okay. Now, can we find this angle? Can we calculate this angle from the information we have in the question? First of all, what is this angle? This angle simply is the angle at point B which the curves make with the x-axis. So how much the curve here is tilted from the x-axis is simply the first derivative. Let me remind you that the first derivative simply is the tangent of the curve, right? And since here I know the curve, I simply can find, I can simply use this relation, which is just tan, let me call this angle here alpha, for example. Tan alpha simply is the first derivative. This is just the elementary definition of a derivative. And we found y prime before, which was just 1 over 50 x. And of course now we are doing this everything at point B, so we are replacing x by 30. So I have now tan alpha equal just 30 over 50, right? So 0, 0 cancel. I can find alpha. Alpha here, if you do the calculations, I found that to be just 30.96. So 30.96 degrees. Now that's my alpha. And now, just by elementary geometry, this angle here, this angle is also alpha, right? So we have both angles making head to head, so they are the same angle. So now this here is also alpha. So now what would be theta? Theta would be simply phi minus alpha, right? So this is the angle that we are looking for, which is 69 now 0.16 minus 30.96. And here I got the answer to be 38.20 degrees. So this is the angle that the acceleration is making with the x-axis. Right. So I hope you found this video useful. Please like and comment and share the video, and let us know in the comment section if you have questions or further suggestions to improve. Thank you very much, and wishing you all good luck.